class, this is chapter 11 called Factoring. In this first lesson, you will see that you know a bit about factoring because you have done prime factorization. We're just going to take this skill to the next level. So let's get going. So products and positive factors. Now you know that a product is when you multiply two factors together. So look at this fact. We know that 2 times 3 equals 6. So the product in this problem is 6, and the factors are 2 and 3. And so there are also 2 other factors of 6. Can you think of what they are? So some factors of 6 would be 1, 2, 3, and 6. We have to count 1 and 6 because 1 times 6 equals 6. So let's talk about prime factorization of positive integers. A prime number, as a review, is a positive integer greater than 1 that can be divided evenly by itself and 1 only. It has no other factors besides itself and 1. A composite number is a positive integer greater than 1 that can be divided evenly by some integer other than itself and 1. So let's look at a few of these examples and tell me if they are a prime or composite number. So 9, would that be prime or composite? This would be a composite number because it has other factors than 1 and itself. It has the factor of 3 because 3 times 3 is 9. So 1, 3, and 9 are the factors of 9. 17 is a prime number because its only factors are 1 and itself. 17. Is 45 composite or prime? It is composite because it has several factors. It has factors of 1, it has factors of 4, 5, 9, and itself 45. Oh, I forgot one. There's also 15. 15 is also a factor. Now, is 31 prime or composite? Okay, 31 is a prime number. No other number is a factor besides 1 and itself 31. Prime factorization. As a review, let's just review a few of the prime numbers. At the beginning of the year, I gave you a hundreds chart that highlighted all the prime numbers from 0 to 100. But just as a review, some of your prime numbers here are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Just looking at these numbers here, do you think the company 7-Eleven had something in mind when they chose those 2 prime numbers to start their company? Anyway, so the prime factorization of a positive integer is the indicated product of all of its factors that are themselves prime numbers. You take the number all the way down to its prime. Look at this number 18. We have 2 times 9. This is a fact of the product, but it is not taken down all the way to its prime. Same with this fact here. 3 times 6 is 18, but these numbers are not taken down all the way to its prime. The best way to bring your number all the way down to its prime is just to do a factor tree. So let me show you an example of a factor tree of 18, and you want to start with your lowest prime number. So we're going to start with 2. 2 times 9. 2 is a prime number, so I'm going to circle that. And then I'm going to break my 9 down further into its prime numbers of 3 times 3. So my final answer would be 2 times 3 times 3, and we always write it with with it in power form, so it would be 2 times 3 squared. Now, you can also factor this. I could have put 3 times 6 and factored it that way, and I would have gotten the same answer. So this is how you break down a number all the way down to its prime. Method for finding the prime factorization. You start with the smallest prime number of 2, and then you go to the next smallest, which is 3, and then you go to 5, and so on. To find the prime factorization of 24, we will begin by dividing 24 by the smallest prime number of 2. So if I start here, 24, and I start my factor tree, I start with the prime number of 2. 2 times 12 is 24. I'm going to circle my prime number. I know I'm done with it. And then I'm going to continue to break down my 12 into its prime numbers. So 2 times 6 is 12. Circle my prime number. 2 times 3 is 6. I've got all prime numbers. This is 2 to the third power times 3. Okay. Example 2a, find the prime factorization of 30. I'm going to start with my prime number 2. 2 times 15 is 30. Circle my prime. 3 times 5 is 15. I have all prime numbers here, so my answer is 2 times 3 times 5. Find the prime factorization of 36. I'll start with 2. 2 times 18 is 36. Circle my prime number. 2 times 9 is 18. I have my prime number here, and this can be broken down into 2 prime numbers of 3 times 3. Be sure to write this answer in its power form. This would be 2 squared times 3 squared. Okay, let's keep going. So find the prime factorization of 97. You use your divisibility rules that you learned a long time ago. I gave you a handout on this. So just really quickly, 2 cannot be divided into 97 because it doesn't end in an even number. 3 cannot be divided into 97. So 2 can't. 3 can't because you have to add the digits together, which would be 16, and 3 would have to be divisible by 16, which it's not. So 3 cannot divide into 97, nor can 4. 5 cannot because it doesn't end in 5 or 0. 6 cannot. And if you go through your whole list of numbers through 10, you'll see that there are no numbers that are divisible by 97, and that 97 is a prime number. So your answer would just be 97. Finding the greatest common factor, also known as GCF. Okay, so a few steps in finding the GCF of 2 numbers. It can be 2 or more numbers. You want to find the prime factor of each number. Repeated factors should be expressed as in powers, just as you did before. Write each different factor that is common to all the numbers. Raise each factor to the lowest power. You're looking for the factor with the lowest power to which it occurs in any of the numbers. The GCF is the product of all the powers found in step 3. So let's find the GCF of 24 and 60. So if I break 24 down, into its prime numbers, this would be 2 times 12, 2 times 6, 2 times 3. Okay, this is 2 to the third power times 3 to the first power. If I do 60 and break it down, this would be 2 times 30, and then 2 times 15, and then 3 times 5. I've got this broken down to its prime numbers of 2 squared times 3 to the first power times 5 to the first power. Now I need to look at step 3. I look for the factor with the lowest power. So there's a common factor of 2 in both. There's a common factor of 3 in both. There is not a common factor of 5, so I'm not going to use this 5. Now I say that I've got a common factor of 2 and 3 in both numbers. I'm going to choose the factor with the lowest power. My lowest power here is 2 squared, so I'm going to multiply 2 squared. Okay, both of these are 3 to the first power. So now I multiply these numbers. 2 squared is 4. 4 times 3 is 12, and that is my answer. 12 is my GCF. Okay, let's find the greatest common factor of 6x cubed and 15x squared. So let's break down in a factor tree 6x cubed. This would be 2 times 3. I have this down into its prime factors, and the x cubed is just going to stay how it is. 15x squared. I break this down into its prime factors of 3 and 5, and the x squared stays how it is. Now step 2, I look for what is common. Okay, let's see, I don't have a 2 in both. I have a 3 in both, so 3 is common. I don't have a 5 in both, so 5 is not common. I have an x in both, so that is common. Now in step 3, I look to see which one has the lowest power. Both of these are 3 to the first power, and my lowest x power is x squared. So I multiply this by x squared. Step 4 is to multiply. So I multiply this, and this is 3x squared, and that is my answer. Okay, so now let's find the GCF of these 3 numbers. So I can break this down into a factor tree. So 5 is a prime number. It can't be broken down any further. I'm going to leave it as it is. This is 5x cubed y squared. This can be broken down into prime numbers of 2 and 5. I leave the x squared and y cubed as it is. The 25 can be broken down into 5 times 5. Okay, so let's do step 2. Let's see what we have in common. What we have in common is we have a 5 in all 3. So that is what is common. The 2 is not common, okay? So I can't use the 2. X is common to all 3 numbers. So I look for, well, I'll just go ahead and write that. I've got X, it's common in all 3. And then Y is common in all 3. Now step 3, I look to see which one has the lowest power. 5 to the first power in all of them, so I keep that. I multiply my lowest x power, which is just x, and then I multiply my lowest y power, which is y squared. So my answer when I multiply in step 4 is 5xy squared. My GCF equals 5xy squared. Okay guys, I'm going to stop my video here. Please work through some problems and understand how to find the GCF of 2 or more numbers. Have fun practicing.